Okay, this is term 3, week 7 Chem. It's pretty easy, it's all like memorizing stuff. Question 1, which of the following increase the rate of reaction between a solid and liquid? Obviously, increase concentration of the reactant, increasing temperature. Remember, when you increase temperature, it increases kinetic energy. There's going to be more reaction rate. But then, increasing the volume, it does not. Okay, if they said increasing concentration, then it would increase, but volume doesn't. Because actually when you increase the volume, it decreases the concentration. By then, increasing the surface area, obviously that's correct. It's one of the factors in the addition of a catalyst. They're pretty obvious. Question 2. Again, which of the following affect the rate of the chemical reaction? Temperature, surface area, concentration. Obviously the color doesn't. Here they said concentration, but they said concentration of the product. That's wrong. It has to be concentration of the reactants. Question 3. How does the increase in the concentration of the reactants affect the product? Okay, when you increase the concentration of the reactants, there's going to be more collisions. Okay, that means there's going to be an increase in the reaction. If there's more collisions, does it decrease the reaction rate? Obviously not. Does it not affect? Obviously no. Does it decrease the collisions? Obviously no. So it's going to be part B. Question 4. They said a block of wood burns with oxygen, okay, at a certain temperature. How can they increase the reaction rate? Obviously, if you cut it up into smaller pieces, that would increase the surface area. Smaller pieces means larger surface area. It doesn't mean because it's smaller pieces, less surface area. No, it's the opposite actually. If you cut it into, the more pieces you have, the more surface area you have. Replacing air by pure CO2? No. We're reacting it with oxygen. Changing it into carbon dioxide would just be wrong. Grinding the wood means making it into smaller pieces. That it increases the surface area and increases the reaction rate. And then part D, replacing the air with O2. That would be correct. Oxygens are reactant, but if you replace it with pure O2, it's going to be correct. Then part E is going to be wrong because they said N2. We want O2. Okay, I'm recording in class. They want a shout out Ziad, Jad, Omar Assar, and Shobaki, and also Michael and Tim Sakhrini. Sakhrini is going to the bathroom. He's gonna see it when he's watching the recording. Okay, that's that because we have free class. Question 5. Which of the following defines chemical kinetics? This one you just memorize it. It's a study of reaction rates. Okay, question 6. Okay, this one's a bit tougher. Okay, a student carried out a following experiment, okay, between sodium thiosulfate, okay, and hydrochloric acid. They reacted this sodium thing with hydrochloric acid and it produced these things, okay. How the experiment went, there was a beaker here, 100 centimeter cube. It contains 50 centimeter cube of the sodium thiosulfate, this Ne2SO3, okay. They placed it on a black cross here. Okay, there's a crossover here. 5 centimeter cube of hydrochloric acid were added and the clock was started, and they carried it out at 20 degrees Celsius, so the temperature is 20. Okay, the experiment was repeated. Okay, they repeated it again using 25 centimeter cube of 0.2 sodium thiosulfate, and they added 25 centimeter cube water. Okay, the results of this experiment and other experiments were recorded in the table down below. If I use the table, here's the experiment. So this one here, where's my pen? Okay, here. Okay, basically after a certain time, blah 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 blah. Okay, they're not really asking for anything, but they're just showing the experiments. So why did they keep the total volume of water same? Keep the total volume same in all experiments. If you see, the total volume is 55 in experiments 1, 2, 3, and 4. Okay, 55, 55, 55. Why? For fair comparison. Would it be fair if I had in experiment 1 I had 60 centimeter cube, and then in experiment 2 I had 10 centimeter cube? Obviously not. It's gonna mess up the results. But that's why you should always keep the same volume. Okay, for a fair comparison. Okay, then they said if it's repeated at 40. Okay, what happens to the rate of reaction? Here we have 20. So obviously if it's going to 40, that means the temperature is increasing. But what's gonna happen to the rate of reaction? Why? Because particles obviously move faster, so there will be more collisions, more effective collisions. And then, obviously, if you go here, back to the thing, they said the cross disappears. So this cross over here, there's an X here. What's gonna happen to it? What's gonna happen is there's gonna be NaCl forming, right? So this is NaCl crystals, all of this. This is what we call the precipitate. So this precipitate now is gonna form and it's gonna block this X that's over here. When they say why does the cross disappear? Because precipitate forms. And then they said the experiment is used again using a bigger volume. The volume up was 100 centimeters. Hala, sorry, 250. Okay. What's gonna happen? Obviously, the time taken to disappear will be longer. Why? Because the reaction rate decreased when volume increases. Because remember, C equals M V. When this volume will be increasing, that means the concentration will be decreasing, and therefore when concentration decreases, then reaction rate decreases. Question 7. They gave you another experiment. Okay, they said hydrochloric acid they're reacting with calcium carbonate, and there's a balance here, and there's cotton wool on top. Okay, they placed it on a balance, and they were measuring the mass, yeah? And as time increased, obviously the mass started decreasing because these two are reacting and they're releasing a gas outside, they're releasing carbon dioxide. Okay, since there's carbon dioxide being released, the mass is decreasing. That's why here in the graph the mass is decreasing. What is the role of the cotton wool? It allows the carbon dioxide to escape. Because cotton isn't like, it's not fully solid. There are like some openings through it. It allows the carbon dioxide to escape while still keeping these reactions inside. So it allows the carbon dioxide to escape, and it prevents, how do you see it in the truth sound like it? It prevents the splashing of the acid. It blocks the acid from splashing out, but it lets the gas go out. Okay, and here it's the release of carbon dioxide gas. That's why the mass decreases. How do you know it's carbon dioxide? I mean, okay, I know it's not obvious, but you have hydrochloric acid, which is HCl. You have calcium carbonate, which is CaCO3. What gas is formed here? Yeah, you have CO3, which is CO2. Okay. Check the graph of the experiment if it's repeated at 50 degrees Celsius. So here they give you the temperature 25. So they said, whoa, did I refresh my accent? Hold on. So here the graph is at 25 degrees Celsius. So if it becomes 50 degrees Celsius, then the reaction rate increases. صح? That means it's going to be faster. Since we're decreasing, will it be here? No, obviously not. We're going to want a faster decrease, right? So if you want it to decrease faster, that means it's going to go down quicker. So it's going to be under it. But suppose when you have a graph going up, and I told you draw the faster one, you put it above it. Because here we're going up. But in this graph, we're going down. So if it would be faster, that means it would just be under it. It would go down a bit quicker. Okay? So that means I would want the graph that's under, which is this one. Okay? So you're going to tell me, why isn't it this one? Because look, they don't have the same product. It's supposed to end at the same product because we're only changing the reaction rate. We're not changing anything to do with the reactants. Question 8. Okay, this is the graph of kinetic energy. Okay, this is number of particles. Okay, so basically they gave you two temperatures. They said temperature 3 is bigger than temperature 2 and temperature 2 is bigger than temperature 1. Okay, so they said just put it in the boxes. Obviously, to the right means as you go to the right, kinetic energy is increasing. Kinetic energy is increasing as you go to the right. When temperature increases, then kinetic energy increases. So the highest temperature will be at the highest point of kinetic energy. And here, since it's the most on the right, this is the highest kinetic energy. So that means it will be the highest temperature. Same thing with 2. It's in the middle. So which one's in the middle? This one. And here, it's the least, so you just take the least. Question 9. Based on the collision theory, a decrease in the concentration of reactant obviously will increase the rate of reaction because the collision decreases. It's pretty self-explanatory. I don't think I have to explain it. Question 10. Then again, if the temperature decreases, okay, decrease in temperature will decrease the rate of reaction because again, collisions decrease. Question 11. Okay, they gave you three different experiments, equal masses of calcium carbonate, excess calcium carbonate, with the same volume of HCl in each experiment. One factor was changed. Okay, the volume of carbon dioxide was released and measured every 5 seconds, blah blah blah. So calcium carbonate is the excess, okay, and HCl is the limit. Okay, what's gonna happen if it has a lower temperature? Okay, if it's a lower temperature, that just means it has lower rate, but the product will still be the same. So which one is slower but has the same product? It's going to be B, right? Because it's a bit slower but it still ends at the same product. Lower concentration of hydrochloric acid. Now we have lower or less reactants. So what's going to happen? Less product. Which one's the less product? C. Okay. Part C, using lumps rather than powdered calcium carbonate. A lump basically is bigger pieces, okay? Bigger pieces. And you know, if it's bigger pieces, that means less surface area, okay? If it's less surface area, what happens? The rate is going to decrease, but will we still have the same end product? Yes, because we didn't change the reactants. So it's still going to end here, so it's going to be again. Addition of a catalyst. We said if there's a catalyst, then there's a higher reaction rate. So obviously it will be A. Question 12. Okay, they give a reaction CH4 to O2 to produce CO2 and 2H2O. The reaction rate can be expressed as the quantity of H2O produced per unit time. Remember, the rate always has to be per unit time. It can't be anything else. Okay? But if it was a reactant, then you would say used up, not produced. But since H2O is a product, we say produced. Okay, question 13. Student added 12 grams of CaCO3 to 200 centimeter cube of acetic acid solution. They said acetic acid is the excess. Okay, and they said the temperature is 80 degrees Celsius. CO2 gas was produced and collected in a syringe. The volume of the gas was measured at regular intervals, blah 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 blah. Okay, so they gave you three graphs. They said B is the original graph, right? Yeah, they said B is the original graph. What happens if we use 400 centimeter cube? Here we have 200 centimeter cube. What happens if we increase its volume or increase its concentration also? It's not only increasing the volume, it's increasing the concentration. Here we had 1 m, here it's 2 m. So how do we increase concentration? Higher rate. But is this the limiting or the excess? It's the excess. So will it increase the product? No. It's just going to be faster. So it's going to be C. It's going to be the same product. 15 grams of powdered CaCO3 was used. So we said acetic acid is the excess. So obviously the limiting is CaCO3, and they increased the reactant. So what's going to happen if you increase the volume, increase the amount of reactants? The product will increase. So that means we're going to take the acid was cooled. Obviously, if it's cooled, that means lower temperature, which is lower reaction rate. So it's going to go down. I think that's it. Yeah, question 14. Okay, the following apparatus is used to prepare oxygen. Okay, a tube of 1 gram of powdered manganese oxide was added to the hydrogen peroxide solution. Okay, it's a tube containing manganese oxide, and in this is a solution of hydrogen peroxide. The tube of manganese oxide is suspended in the flask. Why is it in the flask and not mixed with hydrogen peroxide? Because they want to prevent the reaction between hydrogen peroxide and manganese oxide. Okay, so you're gonna think now, why do I want to prevent the reaction between them? I know some of you only took this today in class, also we took it today in class. But that means if it's suspended in a tube, that means it's a catalyst. Okay? We don't mix the catalyst with the actual reaction, okay? Because that produces a vigorous reaction. The only purpose of the catalyst is to speed up the reaction. Therefore, we don't mix it, we just keep it in a tube plate. Okay? So we keep it to prevent the reaction. So when does the reaction start? It reacts when this cotton string over here is released, when you open up the tube, because it allows oxygen to flow in, or air to flow in, to react with the hydrogen peroxide. Okay? So when the cotton string is released. And manganese oxide in this case acts as a catalyst. When 1 gram of manganese oxide are used, the rate of the reaction increases. Sorry, when 1 gram lumps of manganese oxide, what's going to happen to the rate of reaction? It's going to decrease. Why? Because they said lumps. What's lumps mean? It means big pieces. Bigger pieces. Okay, it means lower surface area. That means less reaction rate. Okay, so the reaction rate decreases because it has smaller surface area. Question A. Okay, when does the reaction stop? Obviously, when we run out of hydrogen peroxide. So when the hydrogen peroxide completely decomposes. Question 15. Okay, there is a point here at 7.5 seconds. Okay, I said it's not on the line because it's a wrong reading of volume. So you're gonna do this if anybody took IG or is taking IG next year. Sometimes you're gonna have graphs with points that are not on the graph. This is because it's a wrong reading. Okay, and if it's a wrong reading, we don't include it in our drawing. Okay, so that's why in this case they didn't include it in the graph because it's a wrong reading. Okay, what volume is collected after 10 seconds? You call 10 seconds. You see, it's 15. So you just put 15, and then now you do the opposite. They say 19 centimeter cubed, so you go to 19. And here you go to the point. It's gonna be 15 seconds, same answer. Okay, then what caused the reaction to stop? Obviously, the reactants are consumed. That's it. Doesn't really matter. Okay. At what minute the result appears to be inaccurate? You just look at the inaccurate result, which one's not on the graph. At what minute? 2 minutes. During the first 6 minutes, the speed of the reaction decreases. Okay, you're gonna have to look at it. When it was, look at decreases. It's going up. Okay, it's going up, but then all of a sudden starts slowing down. So what does that mean? It's decreasing. So why is it decreasing? Because the concentration of, in this case, our limiting hydrochloric acid. Okay, it's the limiting. Okay, as limiting, it's decreasing, right? What happens to the reactant? What happens if the reactant decreases? Then the collision decreases. I think, is there an extra part? Yeah, there's no point. Why is it decreasing? Because we're running out. We're running out of the HCl. We're running out of it. So obviously the reaction is going to start decreasing. Okay, what would happen if it was repeated at 50 degrees Celsius, knowing that the original one is in black? Obviously, if it's a higher temperature, it's just going to be a higher rate. Okay, but remember that the end product will always be the same. This is wrong because it's above it. It's not allowed. It has to be the same product. Question 17. There's a danger of explosion when a large amount of powdered material is used because it has a large surface area. Sometimes the surface area will be too large that might cause an explosion. Okay, when the concentration increases, what happens to collisions? Obviously increase. This leads to an increase in the reaction rate if there's more collisions. Thank you so much for watching. Good luck.